We are OOP3200 in the fall 2020 semester at Durham College, and it's week 10. Object-Oriented Programming 2, we're talking about Java classes. So what's up for this week? Week 10 overview. Our in-class exercise 9 is due Friday. We're going to talk about that. Java Lab 2 is due Sunday. I'm going to talk about that. And then we're going to kind of do a review of classes and objects from a Java point of view. I've also included exception handlers to recover from errors, because you're going to need that for your lab, as well as the Java API packages date and time API. And I'm just giving you a small example of that, so to help you with your lab. Let's look at the lab first. So what is this lab that we speak of? Java. Why does it say standard deck? That's bad. It should say work ticket. See these copy paste errors? They're amazing. Anyway, so you're actually going to be making a Java version of your work ticket class. There we go. That you've done in C++. So that's really the exercise here. It talks here about the attributes you need. So an object of class work ticket has the following attributes: include a set, mutator, and get accessor method for each attribute. So you've done work ticket, and really what they talk about here is testing for illegal argument exceptions when you enter data, and those kind of things. So I think it's these things that you've done before. So again, you're checking between 2000 and 2099. In fact, a lot of the stuff that you're going to be doing here, you can almost lift right from your C++ code, and a lot of it can be imported right here in Java with almost a copy paste. Almost. There's some stuff that would be very different. Okay, and we'll talk about that. There's going to be parameterized constructors. So parameters are not specified. If parameters are not specified, ensure the work ticket number is 0 and all other attributes are set to null. This is your default constructor. So what do you do if nothing is there? We'll talk about the constructor in a bit. Parameterized version should set the object attributes to the parameter specified if they are valid. So if you have a parameterized version that gives you all the attributes of your tickets, just like normal, if any parameters are not valid, an illegal argument exception should be thrown. So take a look at illegal argument exceptions. I've kind of put a little bit of how to handle them, and then we'll talk about how to throw them. Okay, so that's kind of in the end there. You have a setter, set work ticket class, and you're also going to overload or override, the toString, the built-in toString method that is inherited from object. Object is the superclass of all other classes in Java, and we'll go over that today. Again, everything else remains as normal. Instead of it saying C++ files, obviously my copy paste errors continue. It should say Java file. So hopefully you didn't do anything with your your video like that. It's just me. Java and C++ have a very similar style guide. That's how it works. So version control is the same. Your YouTube presentation should be pretty much the same with you and your partner. And that's really it. This thing is all due again this Sunday coming up, and it's the kind of a standard format that we've looked at, 6% of your final grade, and so on. So that's really it. It's nothing too crazy. I think it's really in line with what you already know how to do. And what I want to do now, because we're going to refer back to this PowerPoint. The PowerPoint itself is pretty simple, right? As an example, it really goes into, because we're sitting here right now, week 10. We're actually supposed to be in logic, arrays, and strings. I've entered classes and objects early. This should have been next week, but I've kind of brought it forward, and that's okay. Right, that's kind of okay. Just be aware, though, that next week there is a quiz coming up, and that's Java Quiz 1, starting at week 11. How do we do quizzes again? I'll give it to you in the beginning of the week at some point, and you'll have until the end of the week to get it completed. Okay, so that's kind of the way that's done. Okay, so just kind of letting you know. That's the plan for next week. There's also an in-class exercise, but there is no Java assignment or Java lab 3 that's going to happen next week. So that's good. So no lab next week, which is a good thing. Because, we've been hitting it we're hitting it a couple weeks in a row, and then we're giving you a break with a little bit of a quiz, and then you'll have the next Java lab the following week. So, but in-class exercise will continue to happen. Notice that it says in-class exercise 9. We're actually doing 9 right now, and then that'll be 10 and 11. So you'll have like extra exercises that'll give you a chance to practice. And again, these exercises are very simple. We get together. There is a nice today. We get together. And we, did I not say that in class exercise? Maybe I missed that somehow in class exercise 9, yeah. We get together and we talk, we kind of get a chance to practice. And as long as you're in class and you hand in the stuff that we work on together, it's fairly straightforward. We kind of work together and you get it done. It's pretty straightforward, okay? All right, any questions that about our schedule? So again, we're a little bit ahead of schedule, which is always good. And remember that towards the end, like we're looking at classes and objects are supposed to be next week. Java packages and access control is the week after. And then we have overloading, supposed to be this one. We're going to be ahead. So chances are we're going to hit Java templates and constructors, in class constructors early, right? So our last class, which is reserved here for a in-class exercise and a Java assignment and a Java quiz, the last quiz of the semester and all that kind of stuff. That's still going to happen, but this last class, what we may do is I may give it back to you as an opportunity for you to do your quiz and finish off anything that you need. So we'll see how this goes. If we're ahead, if we continue to maintain a schedule that we're ahead every single time, we'll do it. There's no final project, I don't believe. No, this class has just in-class exercises and Java assignments and Java quizzes. That's really it. There's nothing else that comes in play here, right? So it'll be like that. You go through, you do your assignments, do your exercises, and you're good to go, right? So, and there's no real, I wouldn't say that it says Java quiz 1, it's actually Java quiz 2. But there is no real exam in this course, I would say. I think that's something that which is a good thing. So it'll give some of your time back. You don't have to, go crazy and all that kind of stuff too. Okay, so that's what's kind of coming up. Let's get into what we're doing today. We're talking about classes and objects, and in here, there's some examples. I've just kind of copied some examples in here. Here's an account class, and notice that we have private instance variables and public properties. These are also called, like we talked about before, setters and getters, or set mutators and get accessors, however you want to call them. Notice that in Java, we have to make methods similar to what we do in C++. However, in C#, they do have special methods for get and set. That's not the case here. We don't have that kind of syntax in Java either. So that's kind of the way it works. We declare a class, the class keyword, like normal. We've kind of gone through this before when we did our little dog and pony show in the beginning. But I'm just going to go skip through here because this is just information for you. And there's a driver class. We usually call the main class the driver class of the program. That's how we do it. And this is an example of the driver class where we have main. We've been using that for the last week. That's nothing new. And so example, we would use, just like normal, we would instantiate an object of type account inside of main. Notice we need to use the keyword new every single time, not like C++, but very similar to C#. C# always uses the new keyword for the most part. So that's something we're going to do again. Okay, so that's, again, nothing that's too way out there in terms of what you're used to. And so there's examples here of the account class, okay, so which can help you kind of structure your classes. Default value for string variables is null. Default values for other variables, I believe, are 0. And here's an example of the account class UML diagram that we've seen before. The top compartment is the class name. The middle compartment is the names of your attributes. And the bottom compartment is the names of your operations, which we call methods or functions. Okay, so this is kind of similar. We kind of covered this with star UML near the beginning of the semester. So that's that. Static main is how we do everything. We use the import declarations like we did before. We talked about this very briefly. Import replaces, includes in C++, and it talks a little bit about importing stuff. One thing to know is I like this image because it really talks about encapsulation. This is kind of, to me, a really good image about how do I encapsulate? What does that mean? Again, private data members, public properties. These are your properties, if you will, or your getters and setters, and then it encapsulates or surrounds the name, private instance variable, if you will. So this is a really good picture in my opinion, because it gives you a chance to kind of think about it. And the great thing is when you wrap two functions like getName and setName, remember that they're functions. People forget that you can do other stuff with your getters and setters, whether it's C# or C++ or Java or even JavaScript. You can do kind of the same thing, or even PHP. Anyways, so then they also talk here about primitive types versus reference types, because we're talking about classes now, and it kind of identifies primitive types as Boolean, byte, char, or char, short, int, long, float, and double, and reference types are everything else, including arrays and strings. Those are reference types. All primitives start, this is a key thing for you guys to know, they're all initialized as 0, okay? So that's important to know. And then Booleans are initialized as false, and all other reference types are initialized as null, which is something that we can check for. Okay, so those are differences in this language compared to what we've noticed before. Okay, and I think it's very similar to C++. Initializing objects with constructors, and there's some examples of this where we have constructors here. So again, if you have your account class, you have your account constructor. You take in, this is a parameterized constructor, and you have your getters and setters for your name, and then how to use them. Again, you use the constructor just like normal. Everything is the same. Nothing that's too different. Constructors can specify parameters but not return values. And one thing to note is if you do not include a default constructor, the compiler will not create one for you. Just letting you know. So there is no default constructor by default. You have to actually, if you actually can, create a custom constructor, right, that takes parameters, that means you won't have any default. And the way we do things, there are no optional, values in constructors. You can't just put optionals in there or default values. Java doesn't allow that, right? And we kind of talked about that briefly in the beginning. What you need to do is create multiple signatures for your constructor or methods in order for you to have default values and what to do with those. Okay, so just letting you know ahead of time. So Java has a lot, you might see a lot of overloads as an example for constructors or for methods. Again, if we look at the account class, again, just to remind you what this would look like from a UML perspective, you have the account class name, your attribute, which is string, which is private. Notice that the minus there, it means private. I know it's kind of hard to see, but it's on your PowerPoint. And the constructor is called account. It takes a string, and we have a getter and a setter. Okay, so that's kind of that works. And we have, as an example here, some we've added, in this case, the account also has a balance double variable, and notice that our account constructor here takes, in this particular case, takes a string and a double, right, and initialize those things with the this keyword. A lot of times we can remove the this keyword just like we do in C# and in C++ in many places because it's implied. All right, so that's kind of where it is. And notice that you have other functions, other methods that do things with your deposit values and so on, and it's something similar that we've seen before. Again, this is just examples that I've kind of populated here, so you have something to look at, which is very, very important. I'm just going to skip through here, and I'm going to go to further down where we get to the UML diagram for this one. It's very similar. And then I get into exception handlers. Now you need to use exception handlers like it said in in your program coming forward. We really haven't talked about try-catch too much, but notice that there's different kinds of exceptions. Notably here, this is a file not found exception that doesn't do anything but halts the program. And so what you want to do, you can get errors if you're not careful about exceptions if you use more than one type, especially if you use the same type twice. For example, number format exception. If you do those things twice, it's ambiguous for the compiler, so it won't know what to do, and it'll throw an error for the second one. Okay. Similarly, you guys should know about exceptions and the way it works in terms of inheritance. Object, of course, like any other class, the exception class inherits from object at the end of the day. It also inherits from something called throwable. So that's kind of a middle step between object and exception. So runtime exception inherits from exception. Illegal argument exception inherits from runtime exception. And number format exception inherits from illegal argument exception. So this is kind of like your hierarchy. So this also presents an issue because if you don't know this, and if you try and do an example illegal argument exception as well as a number format exception, this will throw an error because it's like you're doing the same thing twice. Okay, just letting you know, right? So the way to do to do this is to do it in another order. So you want to go from more specialized, example number format exception, to illegal argument exception, which is less specialized. Remember we talked about how as we go down the hierarchy chain for classes and objects, that the classes way down in the chain are fatter than their parents. Why? Because they're more specialized. They've got more stuff in them than the other classes above them, as an example, right, in the chain. So notice that if illegal argument exception and number format exception is a more specialized version of illegal argument exception. All right, to understand that. So we can put it in more less specialized order. So if we said something like number format exception first and then illegal argument exception, that would be okay. Just letting you know. So these are kind of nuances of the Java language, and so you don't want to, if you get some of these errors, I want you to know how to handle them. And this is kind of what's happening. It's going to come to you on Sunday when you start using these kinds of try-catch statements. Also, there is a finally clause in try-catch, and what happens is it triggers regardless of whether you have an error or not. And this is very similar in C# and even in C++. We're also going to be talking about the Java time class. So, by the way, I've given you a reference to the documentation for this API. There's several different kinds of API packages we'll be covering, and Java time is kind of the newer one. It replaced util.time, if I'm not wrong. And I've given you an example here of local date, which is what I've asked you to do inside of your lab. So notice this says Java time local date, and then for you to know how that's done, I've kind of provided you with an example here of how to do that. So notice that date is equal to local date.now, and then what you want to do is local date is really an example of using time zones and how it understands where you are physically to give you the right time. All right, so this is kind of important stuff for you guys for your work ticket class. That's what I wanted to cover. One thing also to note is that in your content area, and I want to talk about that, and here's IntelliJ. In your content area of this week, and let me just put up in my YouTube recordings, let me just put this up now since we're live. I'm just going to make that, before I forget, video, YouTube, and I want to make sure that we're good to go here. Okay, and da-da-da. Sorry, one sec while we continue. Just want to make sure that we are all good to go. So just in case people who need real-time closed captioning support, it's there for you. And that's why I usually do the YouTube recording I put it in there live so you guys can use it instead of watching this feed, or watch it simultaneously. Some people like to do that too. But in the lecture portion, I've also included links up here to LinkedIn Learning. Okay, so that was originally lynda.com, and if we look at that link, you can see that there's several. If I look at lynda.com,
completely different API.
You can see that LinkedIn Learning, it talks about working with dates and times here. You have access to LinkedIn Learning. You should have access to Durham College. We're going to take it away, and the Ontario government, and they've brought it back for us to use. So obviously you can go here, and if you need anything from a Java Essential training perspective, this link, which is working with dates and times, as well as they talk about exception handling and debugging here in more detail. And David Gassner, which I'm happy does use IntelliJ IDEA instead of NetBeans, which is good. That means whatever you're using, he's using. And so if you needed to go through here, and any kind of support on LinkedIn Learning is here for you. They talk about basic things in here as well, and I think this is a good reference for a lot of other stuff. Also, encapsulation is kind of an important aspect to understand when it comes to what we just talked about, which is private instance variables, public properties, right? So that's kind of what we have in there. And if you look at that, those two links are there for you to use. And hopefully, again, you won't have any issues accessing them through Lynda or LinkedIn Learning now. All right, so that's kind of where we're going with that. Let's get into our in-class exercise. I'm going to get right into IntelliJ IDEA. Please pull up this. We're going to start off with some simple stuff. So hopefully you've got IntelliJ loaded. Notice mine updated to 2020.2.3. Yours may have done the same if you left it to auto update. Maybe you have, right? We did a kind of a name person class in the first day. Today, let's think about doing that our vector class from before. We've done kind of a different classes in the past that are similar. We're going to do a vector class which is more complex, and I'm going to talk about how this is done in a bit. So let's do this. Let's go new project, and I'm going to do again just like we did before. You can choose OpenJDK as an example 15 or 1.8. If you get this message, is totally fine. It'll try and detect any other JDK that's in there. I also have 1.8 in there. I'm fine. Either one is okay, right? So next, and we click on create project from template. We're going to do a command line template next, and then Durham College again is what we're going to be doing. We definitely want it to go in the right spot, so it's going to go to OOP3200, and this one is going to be called OOP3200 and the fall 2020 semester, and it's lesson 10. Okay, that's the one. Finish, which should bring you into what we did before. Let's put this up on GitHub, so let's prepare ourselves for what we're doing, just like normal. So again, in order for us to initialize GitHub, we go into VCS, we go into enable version control integration, this option, and then we choose Git, press OK, and when that's done, this does your git init, and just like we've done before in the terminal, you can see that it clearly did that for us. Okay, so that's what it did. Again, this is all review. Okay, so if you don't, please try not to be bored. We've done that, but so we want to do the commit. So the next step, we need to select unversioned files, and we're going to do our simple commit message, which is going to be called initial commit. Remember the two most common commit messages in the beginning are initial commit and first commit. Those are the two ones that we see a lot of when you first do your first commit. And I'm going to click on commit. I can't commit and push because there is no remote, but if we do that, if we click commit and push, it's going to take us to where it says define a remote. We need to do that, and here it provides us with a URL pop-up, and we need to do that live. So I'm going to go up to GitHub, Durham Programmer, where we're going to get this. I'm going to click on new, and I'm going to call this ICE 9 so you guys can follow along. So again, it's going to be OOP3200 F2020, and then it's ICE 9, which is what we're doing today. So again, all standard stuff nothing that you don't know about by now. And then grab these last 3 lines of code if I was going to do it by console, but we're not doing console, we're actually doing this. All we need is this part. And if I go back and I drag this in there and copy it and press OK, that's going to provide my branch. Now, typically we don't call them master anymore, we call them main, but GitHub doesn't care. Master, main, for it, it's the same. We're going to click push. You can also do a pull down, force push. Don't want to do this, it'll overwrite the previous stuff. So let's just do push. If you've done this for the first time, it'll ask you to log in. Otherwise, push is done. Okay, so that's kind of our first step. Why? We want to be prepared to do this kind of stuff so that way you're ready to go. And I'm going to put my link for IS9 for GitHub into our little plan. So I'm going to go back into content. And I'm going to go into ICE in-class exercise, and in here I'm going to put in our GitHub link for week 9 or week 10. So create a link. I'll say GitHub link for week 10. And again, all standard stuff that we've done together before. Nothing that's new. Okay, so now we come to the point where I ask you, are you with me? So check mark if you're with me, X if you're not. And we don't have a lot of people here today. Thank you. But the people that are here are nicely responsive. Thank you for that. All right. Let's clear that up. Thank you. All right, so if you're with me, then we go to the next step. We want to define a class called a vector2 class, right? That's what it's going to be, vector2, right? So I'm going to go into my project files. And if you look here, a couple people had some issues and they said, well, I don't know why, but I can't modify my files. Please, whatever you do, be careful where you try and modify stuff. If you try and go into idea, this part, and try and put stuff in here, it's gonna make your life difficult. So don't put anything in here, that's for sure. What you want is to do in your source ca.durham college area here is where you want to put all your files. You definitely don't want to touch anything that's external libraries in here or anywhere else. Just in here is where you're putting stuff. And CA Durham College. Remember that this is actually a folder within a folder. Because if you look up in GitHub, you can notice that right away. Notice that it says source, the source folder. CA is another folder. And then Durham College is the third folder. So notice that it doesn't have, source has CA and Durham College in it. Right, and if I go to CA, it has Durham College in it, and then Durham College has your main. Okay, so that's the format, and that's how they do packages or namespaces in Java. Just a reminder. Okay, so why am I telling you this? Because people always ask those same questions over and over again. All right, so again, what I'm going to do is I'm going to start writing my code. This is where I'm going to. This is, remember, my driver class. This is what it would be called. So this is the driver class, or you can call it a lot of stuff. This is your entry point to the your Java program. And what we want to do is here, anything that's inside of the Durham College namespace is implicitly available here without using a package. You don't have to use a package or an import statement or anything like that. Okay. So I'm going to go here and go do a new Java class. And we've seen this kind of stuff before, but let's do this together. New Java class, we're going to call it vector2. Okay, here's my vector2 class. We can also call it vector2d. Maybe we'll call it vector2d just to make it different. So vector2d, it says, do you want to add the following file to Git? Yes, I want to add it. So in other words, it's going to be tracked. That's what I definitely want that to happen, right? So again, vector2d. And we've made it a class of vector2d. And remember, we're going to have two variables, x and y, and they're going to be private. So let's format our class how it should be. So here is private instance variables. Anytime we do a class, we should do this. Public properties, which are also called getters or setters or mutators and accessors. So mutators and accessors. All right. We're going to have our constructors. So this is a way of kind of, scaffolding it out. And then some kind of private methods first. I like to do it this way, followed by public methods after. All right, this is kind of what I have. And then sometimes we might have static methods down here, right? And the reason why we want statics is because, just like we've done in the past, we want some classes, to be able to use a static object, right? Where I don't have to instantiate the object at runtime, but rather I can use the class itself with a method to help me out, right, for whatever reason. So let's think about these private instance variables. We're going to use a convention that's simple for these ones, just to keep it simple. We're going to say private x, which is of type, we'll make it a float, right? And private float y. So x and y, this is the vector 2D. We could have made them underscore x and underscore y, but to help us, because I'm a crazy guy, I'm going to right click here and go generate, right? Because we're going to do this really quickly. And I'm going to generate where it says getter and setter. We're also going to generate the toString function. You're going to do that yourself for your stuff. So first we'll start off with getter and setter. So if I click getter and setter for x and y, notice I have to highlight both, right? And once I've done that, it says, by the way, getter template is IntelliJ default. You can make your own, right? So this is kind of an important thing. You can make your own templates for your generated results, which is awesome. It means if later on, if you really wanted to, you can point to templates. We're not doing that. We're just going to press OK. And it gives us everything we want. Set x and get x, set y, and all this kind of stuff is ready to go. We want these obviously after our class, our private instance variables. So to me, I don't like them here. I'm going to take those and put them inside public properties. That's where they're going to go. And I also want to set these up so that they use the same format that I like, which is something that looks like this. Also, what's missing from this with our, well, we used Cartesian point earlier in C++. One thing we're missing is a set, one set function that takes care of everything. Now that is not necessarily a getter or setter, but it's kind of like a set. So if I say public, it's going to be set void, and I'm going to use the capital S for this because it's a function, set. And I'm going to pass in both float x and float y, right? So, so float x and float y. So I'm setting, sometimes we need to do that. And I'm going to say this dot x is equal to x and this dot y is equal to y. So we're going to have that as an option as well. So set itself, or set x, get y, and so on. Those are all things we need to do. Are you with me? Check mark if you're with me. If I'm going too fast, slow me down. But this should be all stuff you know how to do, and you should be happy doing it, because it's happy times here at Durham College. All right, like literally there's nothing going on. All right, thank you for that feedback. Okay, let's move on. So we've got getters and setters. We got our set function, which we've done before many times, and now let's set up our constructor functions. So we were going to do two. One that's called vector2d, right, which is going to be the default constructor function, and this is how it's going to go. If I don't have any parameters, then this dot x is going to be equal to 0, and this dot y is going to be equal to 0. This takes the place of default values in a constructor function. Okay, so this is how it would work. Now let's make another one. So we're going to say vector 2d, and what if I only produce only one of them? So I pass in a single option, or let's say I want to pass in another vector 2d. That's also things. But let's pass in x and y. So float x, very similar to our setter, float x and float y, where we want to say that, just like we did here, I could call the set function. It's really up to you how you want to do this. If you do call the set function, anytime we pass in x and y values, it goes through another function as well. So just keep that in mind. Again, not really that important, but sometimes what we want to do is when we set things, then we want to do some additional functionality. So let's do that here. So we'll say set, and we'll say x and y, right? And you can do that, right? You can use the default value for this. Notice that it highlights or it lights up when we do that. And we could also in here do the same thing, vector2, instead of doing this x and this y. Again, that's something we could have done with x and y. But anyways, let's leave this alone. Let's continue. So we got these two. Let's make one more, right? So we're going to say We also want the ability for us to get a vector 2D, and the vector 2D we want to pass in is another vector 2D. What if I pass another vector 2D? Guys, this is the copy constructor. Vectors 2D, I pass in a vector 2D in there, and then I call it a vector, right? How does this work? Well, what I want to do is I want to take the stuff from vector and pass it into my function. So I'm going to say set, and it's going to be vector.x and then vector.y, which I'm going to pass in there, right? So pretty simple stuff, right? Now this is okay, but wouldn't it be better if I said I want to use vector.getx and vector.gety, and I recommend this instead, right? The reason why is because now it's going to go through its instead of it being going directly, I have access to it directly because I'm in the vector class. So anything that's inside private, I'm good. I can access, right? But I think it's just safer and better always to go through as much as possible into the using the setter or the getters, okay, that kind of stuff. So that's pretty cool, right? Like, I mean, we did this vector, so it'll actually take a vector 2D as well. That's the thing that it'll take. Okay, so pretty cool stuff. So now we've got several constructors, different options for constructors. We can also do some Java docs here and talk about what they take and so on. We'll do that after. Private methods. All right, so let's think about what other things that we want to do with getters and setters. Right now, I'm going to invite you to look at why we would want to do some stuff like this in the future. Notice also there's a little symbol here that says @ it says insert not null on parameter vector. It's giving us a hint on how to do that. But notice anywhere else we didn't get that. It says Jetbrains annotation library is missing. Without the library IntelliJ IDEA, I cannot run the analysis. Would you like to add it? Sure, add it in. And I'm cool with that. And so what that does, the annotations, what it does, it says that, you know what, vector 2D cannot be null. Right? Can't be. We don't want to pass in null here. Otherwise, we're going to have a problem with our setter, right? That we pass in a null value. Right? So that's kind of cool. I also want to generate in the public method area. I want to generate my toString method. So let's do that now. So again, I'm going to click in there, right click, and go to generate, and then I'm going to generate my toString method, and it's going to say on what, X and Y. I'm going to press OK, and then replace some of the stuff that's in here. Notice it uses an @override, basically annotator. It's an annotation, @override, right? Also it's also called a decorator. And so we're saying toString, well, we want to be able to do this, but what I want instead is when I return something to a string, it's going to be actually looking the way I want it to. So I don't want X and Y to be there. I want to actually just specify X and then comma Y. That's how I want it. You guys can do it different ways, but this is me. And like so. So that's how I want my toString method to work. So now you've done the toString method, keeping it all consistent here. And that would satisfy requirements. Again, make sure you put these. I kind of have this, I try and keep the same structure with everything else. Pretty straightforward stuff. I don't include a \n because we may want to use X and Y coordinates in some way. Okay, so that's kind of a public method, toString. We have that. We may have other methods too. Like I want to find the distance to from, or methods that allow me to add, subtract, multiply, divide, all those kind of things. I'm going to invite you to look at a library that we have access to from before, which is our in our Vector2 class. So I'm going to bring up, just an example, our old Visual Studio projects. So I'm just going to go into my code for a second. And this is kind of similar to what you're going to be doing when you make your lab coming forward. You're going to look at your old Visual Studio stuff for C++. And what my expectation is that you'll be able to look at it and go, how do I convert this? How do I do this? How do I convert this into, something that's more usable? I'm just going to look at it in 1 sec. I want to make sure that the class is there, and it's not. So make sure that it's there for what we're doing. It might be an ICE that I have it in here as, and I have a math library. Here it is, and Vector 2D. All right, so it is from lesson 3C when we got together and did this one. So I'm going to bring this up. This is the project from our C++ time together, and I'm going to bring up this this project here. So let's drag it up. There's Visual Studio 2019 for you, and we have some methods. You're going to do the same thing. We have some methods. Here's something that might look very familiar to you. I wanted to kind of do this kind of idea as well as what we've done before. So I'm going to go into my .h file for my vector 2, and let's see all the other stuff I did for you, right? So copy constructor we really can't do. We just kind of did it when we pass things in. There is no overloading operators in Java. You can't do it this way. You need to do add, subtract, and so on. So if we're going to do arithmetic operations like this, then we need to do it by hand. And let me explain how this looks. Again, notice that there is no interface file for Java. So let's go back to we're going to keep this up, and so I can show you what this looks like while I'm reminded. So I want to make some public methods that allow us to do things like adding, subtracting, multiplying, dividing, all that stuff, vectors. And the way to do that would be, well, maybe not the most brilliant thing to do, but we would do something like public add, right? Where you have two vectors. It's going to return a, when you add, notice what this will do. This will modify the original vector. So we're not going to take anything. It's not going to return anything. It's going to return void. So public void add, and normally what I like to do is put a capital on mine, but I'm just going to go with the Java way for this one. The only one I did capital is the S for set, which theoretically I shouldn't. You know what? Let's go change it back to its normal style. Normal style says lowercase for Java. I'm okay with that. So let's just fix up these things. Okay? Just this way we're not going to have, I'm not going to go against the style guide. Me, I like to make everything caps, but that's just me. Okay, so add, and then we're going to take in two vectors. So we're going to say vector 2D, and it's going to be kind of the left-hand side, right? Which is, actually, all we need is the right-hand side. We're going to add another vector 2D to this one, right? So all we need is one, the right-hand side. And in here, what we're going to do is we're going to say that, so I want to add to my current one. I'm going to say this dot x, right? And again, notice that it provides this dot set x, which is a better way of doing it. I want to go through the setter. So this dot set x, and I'm going to pass in the right-hand side x plus this x. So I'm going to say that this dot get x, right, plus right-hand side dot get x. All right, so that's what's going to do. That's the add, right? And I'm going to do the same thing for the y value. So now this is kind of verbose, I would say, because get y and get y. Okay, so that's kind of what that looks like. So this is kind of an equivalent to a plus operator. It's kind of the same thing. And if we look at it, if we go back and look at our operation, so instead of using the .h, let's look at the .cpp as an example of that. So here we have our plus operator, and look what we did. Same thing, right? Maybe what we can do is we can use the same structure for the minus this time. And notice it says return this. We don't have to do that because we're not actually doing the return. Ours is a void type, all right? So again, if I was going to do subtract, so again, we call public void subtract from the right-hand side. And let's do the same thing this time. Let's actually grab, you can use the set method to do that because we have set. And we can, instead of doing it this way, set x and set y, you could do it this way, or you can do it with one big one like this. Let's see if we can do that. So I'm going to grab this. and paste it in. And notice it says, yes, we can, but it's all lowercase because we've been using get and set, and that's totally fine, you know, from a from a C++ perspective. It's the same. Set X and set Y, we can do the same. We can do it this way as well. This works out to be the exact same. There is a difference, and yes, we can do this, but if we're doing it this way for add, then we want to try and have the same structure for subtract. Not because this won't work, but also because we're going to go through the same, I'm putting it out there to you, the same getters and setters. The same getters and setters. So if I had extra information here from a tracking perspective, I'd want the subtract to be tracked the same as the add. So let's not do this. Just for this example, we're actually going to do it this way. And we're going to just put a negative here. Okay, so anything on the right-hand side is subtracted from the left-hand side. Well, if that's the case, we can do multiply and divide. I'm just going to copy-paste the whole thing now. So multiply and divide. Here's multiply. And this is divide. From the right-hand side, and just swap out the symbols. Right. And we may want to try to do some kind of division by zero check here, but we're not doing that. All right, so that's kind of some operation methods: add, subtract, multiply, divide, those kind of things that we want to do here. Let's go back to this. What else do we have? We have equals operator as well as not equals. Okay, so again, how would this be? Well, if you want to compare, right, then we could do that. We could say something like public. Now, remember what this does. To do a comparison, we want to, should it be it's going to return a bool, right? So it's going to say public bool, right? And I want to say something like equals, and I'm going to take my vector2 on the right hand side, vector2 on the right hand side, and let's see what that looks like. How do we do that? Well, it'd be the same as what we're used to doing. Let's see what we do here. Well, for equivalency, we're saying if this one is equal to this one and this one is equal to this one. I think this is a pretty good way of doing it, so I'm going to copy paste right from C++. And what we need to do is just change the names here because they're not uppercase, they're lowercase. That's okay. All right, there we go. So that's kind of almost identical, but it gives us a bit of an error. So let's see what the error is that it gives. It says make equals return Boolean, right? Right? That's what the thing is. It returns a Boolean. We put bool because we're thinking C#, C++. Boolean is the way to go. All right, so that we know this, and if we want to do not equals, well then we can say not. We could call this equals or not. Not means it would be reversed, right? But we can also check if this is not equals by basically reversing this, put a not symbol in front. So we're not going to do the not version of this one. How about greater than or less than? I'm not sure if it's really relevant, but we could do something like, well, if it's only if it's greater than if both are greater and both are lesser, and that kind of stuff. And there's a bit of an error here in my code. It should be both lesser. But anyways, let's correct that for future people that are going to use this thing maybe. And same thing goes with greater than or equal to and less than or equal to. We're not going to do that. The overloaded index operator is not available for us. We can't do this in Java, so it doesn't allow us to do this kind of stuff. So we've done this. Operator plus plus, we would have to call it increment or decrement. Doesn't make sense, so we would use this kind of stuff here for our custom iterator, right? That's not how it would work here. And these are overloaded input, an input stream and output stream, which we wouldn't use. We would use our toString method for primarily. So we're kind of getting through the weeds here in terms of setters and getters and setters, and there's our toString method, right? So pretty straightforward stuff. All right, now we have some other functions like get magnitude and get squared magnitude and set scale and get normalized and a bunch of other stuff that we may want to use. All right, so magnitude is pretty important because we want to get, it's almost like the distance between the origin and this particular object. Now notice that it's const. And we also have further down, I'm just going to put it down there for you guys to look at, that there are other ones that we can use too. Min, max, and 0, 1, 2, 3, 4, 5. These are static methods, right? Where it returns a vector 2 from some of this. So one thing to look at is when is it static, and because it doesn't tell us here in C++, and when is it not static, right? So let's take a look. So if I go into vector2.h, again, I'm converting. So you can see here clearly that I can do getters and setters, and then these ones are utility functions, and these ones are all static functions. So get magnitude, set magnitude, all these things. Let's do these. So get magnitude, get square magnitude, set scale, get normalized, normalize, and all that kind of stuff. So let's do get magnitude. So I'm going to copy this and this. All right, so I'm just going to copy the name, and we can reset it in a second. So over here, so public get magnitude, which returns a float. Notice that there's no const. Remember, const is a different thing in Java anyway. It's final. So can I do final? Nope. Right? Doesn't allow that kind of stuff to happen. Right? So, and if I type it in, by the way, and it gives me a little bit of a light bulb. It says make vector2 class initializer not final. Right? So, yeah. So that's not cool. And what we want to do is want to calculate the square root, because that's what this does. If I go to definition for a second, go to definition. Oop, I'm back. I meant to go to this, go to definition. And so what we did in the C++ version is I cast everything as a double, right? And then after I cast it as a double, I converted it back to float. Why? It gives us more accuracy. We're not going to do that here. We're just going to say math.square root, right? So let's do that. So I'm going to say math, our math library, math.square root, right, is what we want to use. And we want to pass in the difference of the difference of x's, right? Where I multiply x and x and add y and y together. All right, so that's what I want to do. So x and x and y. So we're going to say this dot get x times this dot get x plus this dot get y times this dot get y. That gives us the magnitude. And that's going to be our return. All right. We got a problem, and it says that provided is double, required is float. Why? Because math.square root returns a double, right? Remember, this is kind of what it does, right? Double precision. So we want to cast this whole thing as a float. So we can say that, what if I just did that? If I said float, right? Let's put it in brackets just to make it super explicit. Can we do it this way? Is that good enough for casting purposes? Is that going to satisfy requirements for us? And the answer is yeah, it will. Right? It's kind of an old C style, conversion, but nothing too crazy. It also gives us some hinting, right? So it says, hey, change the axis modifier, right, as an example. And it talks about a bunch of stuff here. We also can do things like show. We want to kind of generate our annotations and stuff. We'll do that after. So get magnitude is actually the distance, if you will, from the origin. Okay, that's what it is. So the magnitude of the vector. Okay. Square magnitude is not using square root. It just multiplies things together. So it's like magnitude, but get square magnitude is safer in many ways because we can confirm, compare squared magnitude with other squares as well, so we can avoid using square root in a very intensive function. So let's do squared magnitude. So we're just going to copy this whole thing, and we'll call this get square magnitude. I think I called it SQR, lowercase SQR, get square magnitude, where we don't use the we don't need to use the math square root at all. So kind of one of these. We just multiply our x's and y's together. Right, that's square magnitude. Set scale. So here what I'm doing is I'm scaling up. I'm using a scalar to scale up my vector. So this is what I want to do. So set scale, public, again void. It's going to modify stuff. So I'm going to say set scale. Right, and set scale is I'm going to have some kind of floating scale. Now you can do a couple ways. You can use the scale actually can be where I use a vector 2 to scale both x and y, right? Where I can modify them differently, or I can use a scalar that is a float. So I'm gonna have an overloaded function for set scale here. All right, so one that is going to use the floating point value. So for example, the scale. And this is going to basically say that I want to say that this dot, we'll say set instead of set x and set y this time. I'm going to take this dot get x multiplied by scale. I want to do that. Now can I do that? So if I said multiply by the scale, well, yeah, because this is a float, right? And I'm multiplying it by a float. This is good. And then this dot get y multiplied by scale. So that's kind of a one thing. So that'll scale both x and y equally, right, with one number, a floating point number we can pass in a float. Or what if I had another vector 2 and I want to scale up an object by a vector 2? So I can do that. I can say vector 2d scale, and then what I would say is scale dot x would be here, multiplied by scale dot y would be there. So that way we can scale it up asymmetrically, potentially. Maybe something where I want to scale more on the x than on the y. So I want to have that option. And so this is a good example of an overloaded method, right? Similar to what we did when we did our overloaded constructor. Okay. And finally, we want to do normalized, get normalized, and normalize. So normalize modifies the actual object. Get normalized, what it does is it returns what this thing would be if it was normalized. So notice it's using this one, get normalized, actually returns normalize, right? Which is something that is happened. And notice I'm saying vector2.normalize. So that is an issue because vector2.normalize actually modifies, well, I have to do this one before this one. That's what it says. Let's do this one first, normalize. So normalize, what is normalization? It changes a vector's range between 0 and 1. Okay, that's what it does. And we need to use the magnitude of the object as well. So good luck we did magnitude here. So get magnitude. So we're going to say public void and then normalize. And we're going to take in nothing, no parameters for normalize, like it doesn't do here. And what this is going to do is it's going to basically say that our magnitude is going to be this dot magnitude. So we're going to say that var magnitude is equal to this dot get magnitude, right? Does that make sense? So I'm saying, hey, I want to make magnitude, this little magnitude variable. Remember, we can use var instead of auto. right? Again, for your, we're just replacing this. And then we can compare. If the magnitude is greater than some really small value, right, then we're going to do it this way. Otherwise, we're going to do it like this. And it says this is equal to vector2, 0. Why? Because if the magnitude is really small, right, a really small magnitude, then it's going to be 0. So it's going to be closer to 0 this way because it's hard to make a real number into 0. And it makes more sense. It'll make it nicer for us. So we're going to use this same if statement for a second and modify it. So copy it and go back into here and paste it. So instead of static cast, we're not going to static cast anything, right? We're going to say that if my magnitude is greater than this, right? This actually is a number that can work. If you want to static cast so that it's a double, just like it did here, we just have to do double. So double magnitude is greater than this, then let's set x and y according to our magnitude, right? We're going to save it to double and then return it as magnitude. Cool. Otherwise, what I want is we want to cast everything as vector2, 0, which means we want to make the x and y coordinates 0, right, for this thing. So we can just say that. We can say that set x and set y for now. Set x to 0, right, and y to 0. That's kind of what we're saying, right, when it comes to what we're doing, right? So either it's going to be some value, some magnitude, or make it 0. This set x and set y to 0 we will replace later on when we have a static function, which we do not have right now. Okay, so I'm just going through the structure here that I'm going through. And finally, we want this one, which is get normalized. So get normalized returns a normalized value without normalization. Okay, so that way it doesn't modify the vector2d itself, but just returns the value if it was normalized. What if it was normalized? It's asking, give it to me, right? So public get normalized, right? That's going to return a vector2d. So vector2d, and we'll say get normalized, and get normalized of this vector. Notice we're not passing in a vector. It has to be of this one. So this dot get normalized. That's what it's going to be, right? So we're going to say something like, just like we did before. Let's just copy this and see how it works. Maybe this will even work properly for us. Copy and paste. And let's see what it does. So we can't use this, but we can do this. It's not bad, right? We have to use the new keyword here. We're making a new vector. So it's very close to what we would do in C++. Very close. That's what I'm pointing out to you. So when you do your work ticket class, guys, this is why I'm doing all this work for you. Look at your C++ code and see how much of it you can transfer in so that you don't have to work so hard, you know? And that's kind of the exercise, right? All right, so this is kind of, I believe, the end of our utility functions, because if I look at our .h file again, normalize and get normalized ends utility, and there's a bunch of static functions. Now we can't do all of these because we don't have time, but let's do some of these ones: 0, 1, up, down, right, left, all these ones, and they're static vector2s, right? So here's static methods. We didn't do any private instance methods so far. Okay, we know private methods, but we do have public methods and some static methods. Let's do that. So we'll say static, and it's going to be public static. That's how you do it, right? And then under public static, you put in the name of the object, so 0. So it returns vector2d, and it's called 0. And what this returns, if I'm not wrong, is a new vector2d that passes in 0, 0. Yeah, that's how it works. Okay, so that's kind of vector2, 0. And this makes sense, right? Because I want to use vector2, 0 instead of doing this. Instead of me figuring this out, I can use the constructor function to do it this way. So then I'll just do that. I'll say that I want to return, right, a new, I want this to be a new vector2. Remember how I can set? I can set way up here. What do? I said that I can set two things. I can pass in a vector, or I can pass in x and y coordinates into my set. Let's pass in a vector. So down in here instead, I can say that I want a new vector 2D dot 0, which is totally cool, right? So I can kind of do this, vector 2D dot 0. But there is a problem. Okay, so let's see what the problem is. Now, I'm supposed to get a vector, right? A new vector 2D. It says create method set in vector 2D, right? And more actions. It says create a method set in our vector 2D, right? Well, we do have vector method set, do we not? So what is it talking about? How come it's not accepting this? Anyone have a clue, an idea? What did I do wrong? Did I do anything wrong? It says expected 2 arguments, but only getting 1. Wait a minute. I gave you 2 arguments, did I not? Up here, vector 2D. Right. Well, yeah, this is the constructor function for vector 2D, where I can take a vector. But did I ever set the set method to take a vector? No, right? That's what it's asking for. So let's do that. So public. And we'll make this take a vector 2D. That's more reasonable. And we'll call this vector. And we'll say that this is equal to vector.x and vector.y, right? So that is your set. Notice that that lit up immediately because I was using it before I made it, right? So I got an overloaded setter. We can do that here. And down here, you can see that that's okay. And so is this, which makes it actually speaks to it more, right? So I'm going to set anything I want to set to a default value like 0, I can put here. Now you got to be careful because sometimes what you'll get is some really weird runtime errors if I try to do it here, right? This is in the constructor function, and I'm saying, well, go there and set it to 0, right? Okay. We can try that. So we can say, let's in the constructor function. What if I said I want to do, this, right? So I want to set, and then I want to set vector 2.0 in here, vector 2D.0. Can I do that in the constructor? It doesn't give me an error, but we may find that this gives us an error later on. Okay, I'm just letting you know. Okay, so kind of what we can do. Let's move down to some of the rest. So 0 is 1. We can also do 1. Let's do the other one. So 1 is the other one we can do. 1 would be just 1 on both x and y. Sometimes we want to multiply by 1 in terms of our matrix calculations, as an example. Then we also want left, right, up, and down if I'm going to move things around. So left, let's start with left. I'm doing in some random value. So on the x-axis, we're going to go to a -1. On the y-axis, we're going to go to 0. So we're going to kind of, I want to go to the left. All right, I want to go to the right. Right? I want to move to the right. Well, then I put this as 1. Right? I want to move up. If we're using Cartesian coordinates, then up would be positive on the y-axis and 0 on the x-axis. Right? If we're using some other coordinate frame, then it could be different. It could be negative on the up. For example, if I'm drawing on a 2D canvas in HTML, then this would have to be negative because positive y is down, right? Because we draw from the top left corner to the bottom right corner. If we're drawing in Cartesian coordinates, then it's the bottom left corner that's 0, 0. And this is what we're assuming here. Okay, so copy and paste down, and then this would be negative, right? So these are all standard values, and this is kind of a interesting public static methods we can use if I want to set things from a calculations perspective. So these are neat. Let's do Lerp, and let's do, I'm not going to do some of the other ones. Okay, there's too many to do. I want to do Lerp and dot. Those are very, there's a lot of them, and maybe min and max. Okay, we'll do those. Lerp, dot, min and max, and we'll be done. All right, and then we'll test it. So what's Lerp? Because we can't do all these things like I said. Lerp is linear interpolation, where I want to, calculate from one vector to another. I can have a t value and I can calculate the kind of the middle distance between t values, and we'll talk about that in a second. So let's get into Lerp if we can find it. 0, 1, 2, 3, 4. Lerp. There it is. Lerp. All right, so this is what our Lerp function looks like. I want to try and copy the entire thing. What if I just did that? What if I did this, copied it, and then went back? Can I fix it? Is it easier to do this, you know, as an example, as opposed to what I did before? Well, this is okay. I can say public static in front of it. Vector2d is the return type. I don't need to explicitly tell it where it comes from because it's in the class. It's called Lerp, which we should say lowercase l. There is no const, but can I use final here? Can I use a final? And now I'm saying ampersand. I'm kind of using the reference. Well, when I pass it in, I always pass by reference, by the way. Can I do final? This is the stuff that that we can think about. Can I do final in here instead of, the way it's done before? And it says Lerp. If I hover over, it says method Lerp is never used. Yeah, but we're going to get into this. We're not right yet. The t value, all right, t value, which is something that we have in here, is going to be math clamp. We don't have a clamp method for math, right? So let's take a look at math f clamp that I produced from 0 to 1 and actually do that little function in here. If we never had to do it again, it's okay. I'm not going to make a math f library here. But if I go clamp 0 to 1, go to definition, then all I'm doing in clamping 0 to 1 is do one of these, where I'm taking the value and I'm saying that if it's less than 0, if it's equal to 0, and if it's greater than 1, it's equal to 1. I don't want to let it go higher or lower than 1 or 0, right? So it's clamping the value between 0 and 1. This is pretty standard stuff, right? So we're going to copy this little piece here. And we're going to say that, so if double t, if double t is less than 0, then what I want is t to be equal to 0. T is equal to 0.0f. If double t, so we're casting it up, we're upcasting in this case, double t is greater than 1, then we're going to make t equal to 1. Okay, so that's what we're going to do. And that's what this function just did, this part. So we can get rid of that. All right, so we're clamping. So let's make a note, clamp t between 0.0 and 1.0. We don't want it to go beyond that because that t value is going to make it go from kind of one side to the other. And then what we want in the return value is we're going to say, let's return a new, has to be new, a new vector2d where a get x plus b get x minus a get x. This is the value times t, and then y get y. And let's just leave this over so you can see, plus b get y, and then a get y times t. So this is the linear interpolation value. And again, it says a couple things. Typo rename to, save Lerp to dictionary. I recommend it. We're going to use Lerp in all kinds of ways. So save it to dictionary so it doesn't give us that little underline. But that's it. That's our Lerp function. And we just took one almost directly from C++ this time and put it in. I even used final in here, right, for setting, right? If we can do this, final, right, what effect will it have in here? Well, that means that when we take parameter values up here somewhere, like, for example, scale, right? This should be also final, no? Right? So final, shouldn't it? And which makes it type safe, so I can't modify scale. And same thing with this one, final. And anything else that I modify, so final, as well as all these should be final too, right? Because all I'm doing is using them, I'm not actually modifying them. And Let's just finish this up so you get the idea of how this works. So we're going to get more and more closer to Java. Not null, let's take not null away, and we'll make this final. So whenever we get a vector, we can't modify the vector, we're going to use it, right? And same thing with vector float x and float y, right? We're going to make those final too. So we can do that, right? Same thing here, final. These are all consts, basically. That's what they are, right? Which makes sense, because this is what we would have done in C++, equivalent. Woohoo, right? Lots and lots of stuff that we've done here. Not null, we don't need anymore. We don't have to import that anymore. Go down, since we've gone through it. Okay, so all those kind of things. We've got lerps and everything else. Let's go through and let's do the last ones, which I'm going to go back to .h, the vector.h. So we did lerp, and I said I wanted to also do dot, right? Because that's kind of an important one to do, dot product, right? So again, let's go to definition and see if we can do it by copy pasting. Go to definitions to save us some time. So when I grab all this, right, and I'm just going to go into the bottom here and paste. I'm going to make this, oops, I'm going to make this work so that it is made it into a breakpoint here. So const we can replace with final. Let's see if we can really do this now. We can take away the ampersand because it's always by reference when we pass stuff in. We can call it dot, lowercase dot, and we can make it public and static. Public static, right? Static cast floats would just be float, like so, right? If you're going to do that kind of thing, we don't have to do this, but I'm doing it anyway just to give you an idea of how you could translate from one language to the other, right? So that way it's not so difficult, right? I mean, and you know, if we're going to do this, let's do it right, you know, kind of thing. So so get x and static cast double, and then get y. Let's see if we can do everything that we're supposed to do here. All I'm doing is replacing. All right, and let's see if we don't want to break on that thing. We want to make it look like this to make sure that we are good. Okay, so that's what it should look like. Return float of this, and this is the dot product. What do we do wrong? Get y should be capital Y. There we go. All right, so that's dot product. That is lerp, linear interpolation between two vectors, and we've done a lot of functions. One thing we're missing, and there's one thing that I don't like, is the distance. And a lot of times I said get the distance. Is there a distance function for vector 2, right? Because I got you guys to do it. So yes, sorry, we'll do one more. I'm sorry, I lied. We're supposed to do distance as well because we can't do distance without it, right? So go to definition. Hint, hint. This may be on something we get you to do in the future, right? So I'm going to grab all this, and I want to grab this distance function again. Copy paste. I'm going to go into here. And at the bottom here, let's do it again. I'm just for completeness, I'm going to space this over. And same thing with this, just to format this properly. Again, it's going to be public static. Let's do that. Public static. We don't need this part. We can call it distance with the lowercase d, just to make it so that it makes sense. This will be final, and this will be final. And we'll also put these like so, A's and B's. Const auto, final var. Is that possible? Let's see if that works. So final var. Can we do that? Yeah, right? Look at that. Final var. Const auto, final var. Static double, well that's just this. So we just cast it as a double. Cast it as a double. Cast it as a double. Right? for increased precision. That's all it is. Could I do copy paste or find replace? Absolutely. I'm not doing it. I'm doing it by hand. And then return math f square root. We don't need math f square root. We can use math square root. So math dot square root. And then we're going to static cast float. So static class float is looking like a float. Of delta x and delta y, but actually what we want, math square root is on the is a double. We want to kind of do it like this. And let's make sure we take these extra brackets away. It's like magnitude, but we want to do is between two vectors. So let's put it like this. So that way we're clear. All right, so there we go. And that is your distance formula. Okay, so distance formula, we did finals. What we did, anytime we do an auto or a var, we can do a final too sometimes, right? So that means going back up here, if we have some stuff that we've done up here where we want to make it so that it is a var, like magnitude. Magnitude is not going to change, right? We're not modifying magnitude, and it's a var. We can put final var. Right? And it makes it more type safe, I think, is the way to go. Let's see if this even works. Like this whole thing may just fail, right? So what about our testing, our driver program? Well, let's go back to C++ and take a look at main. Can I transfer some stuff from main, all this work that we did in main, can I transfer this back into Java? And we'll do this the last part. So we'll grab all this. And then we'll replace all this stuff with other things. Okay, just bear with me. Signed angle, I don't want to use. I didn't transfer this, so we'll come up to maybe up to here. All right, so this is the stuff that I've got. Again, this is from that project solution OOP3200 F2020 lesson 3C, which I share with you on GitHub. But if you're following along online, that's fine too. So if I go to main, I want to test it. And if I copy paste in there, so we can't really use, this worked. So 0.1, this worked. But in order for us to do this, we need to say 0.1 is equal to a new vector 2D. We need to do that first. Because remember, we need to use the new keyword every time, right? Same thing here. Let's do this thing. So new vector 2. Okay, so empty vectors. Here, I want to get a cout that does stuff. Well, this is kind of like a printf equivalent, or we could use a system.out.println. So system.out.println, right? And if I can print out system, and this surround this stuff, right? I mean, I could totally do that, and that's okay. That's what cout is. Let's do the couts. So anytime there's a cout, let's do a system.out.println. Okay, let's do that. So Control A, Control F. So I'm looking for a I'm looking for std cout, and I want to replace with. Let's see how you can replace here. What is the replace function here? Find. Where's replace? I don't know how to do that in thing. Maybe you guys know how to do it better than I do. What is replace? Control F. Could I paste it into chat so I can grab it? Yes, I can. Hold on a second here. You mean all this, right? So yeah, I can do that. Here it is, guys. Which some of it is already there for you. Yeah, so how do you do that? That's find. And if I pull this little thing down, I think it'll do words, match case, regular expressions, open find tool window. Yes, yes, yes. This is my find tool, but I want to replace. How do I do replacements? Group by, expands, finds greatly. Like nice, really, really beautiful. I love the way this works, right? But that's not what I'm looking for. I could have done it by now. That's the craziness, right? I could have done it by now. Replace, which is Control R. Yay, okay, cool. So I want to find CD cout, and I also want to get rid of those things and the space, and I want to replace it with system.out.println with that. And let's do replace all. Right, there we go. The ends I want to replace with an end. So let's do that too. So again, I'm going to look for standard endl, right? And I'm going to replace with this like that and replace all. Pretty good. Okay, so we have some things in here, but that's okay. These are just pluses. And we want to do a toString for 0.1 and 0.2. So 0.1 dot toString, right? That prints it out explicitly. And same thing here. Okay, so that's explicit. Fixed, we don't have to do fixed, but what we can do here instead of print line is printf, which we'll do in a second. So we'll get rid of this. We don't need this part. Again, we're just adjusting. Get magnitude. These are normal. Get magnitude, but we want to use, instead of print lines here, we want to use printfs. For anything with precision or formatting, we want to use printfs, where we say that we want to inject it here. So %f, and we want to have the precision that we want, and I believe the precision was 3 decimal places. So 0.3f, right, is what I want, comma, and then 0.1 dot get magnitude, right? So that's what kind of that is. And %3f, comma, and then 0.2 dot get magnitude, right? So that kind of does that. And then distance between 0.1 and 0.2 is a vector2 dot distance. Again, I want to use printf, where I want to do % this, right? %.3f, and then I want to use comma the vector2 distance between 0.1 and 0.2, and why is it giving me an issue? Vector2 distance. Oh, wait. Okay, why? Oh, duh. Vector2 distance is that's our static function. Okay, so that's pretty cool. So far, so good. Now, scanner, right? How do we do scanner from last week, guys? Remember we did this whole scanner example last week. These are the 2 pieces we need to replace now. Let's go. I want a scanner and a keyboard. Does everyone remember how to do that from last week? Can someone help me out? Because it's the last part, and then I'll let you guys go. How do we do that? Scanner, keyboard is in use, system.in. Awesome. So that's what we want to do this here. So under here, we have to set that up. So scanner, right? And then we say keyboard, right, is equal to a new scanner, where we want to use a system.in. Okay? And it says, do we want to use the util scanner? We want to say, Alt Enter for that, which gives us our import. Okay? So once we have keyboard, how do I get input now from the keyboard? So now I've got the keyboard in, So keyboard dot, and then I want to have some kind of entry, right? But I'm getting a point. I can't get a point, right? I need to do X and Y, and I want to scan something else, right? So how do I do that? This is going to be a couple of steps here. Next float, but I want to do two of them, right? Next float, right? So if I do keyboard dot next float, right? That's only for one, X and Y, right? So how do I do that? Should I do it again? X and then Y? Do I have to ignore the middle one? Because I'm going to enter a comma, right? X, comma, Y. That's what I'm telling it to do. So how do I do it? So I do keyboard dot next. Again, be careful how this is done. We can try this out. And keyboard dot next float. Could be like this. Could be. And what we want is these ones here to go somewhere because it returns something, right? Next float returns a float, right? That's what it does. It returns a float, and it has to be going somewhere, right? So it's almost like we need these pieces in our setter, right? So can I do something that looks like in one line, something like point1.set, and I want to do keyboard. Can I do this? Is that possible? Would the setter allow this? Is my thinking. And then this one. Can I do this? Is that allowed? Can I do this part and then not do the next? Is that something that we can do? And I'm just going to comment this out for now. But the idea behind this is nice. Don't know if that's going to work, right? We have to test it, and that's the only hiccup that we're going to have is the inputs for a second, and then we'll figure that out. So we're going to do the same thing with this. Is that possible? Is the question, and let's see how that works, right? Let's run this thing and see how it all works. Does it work at all? Am I going to get some kind of crazy error? You know, what do we got? Okay, I'm missing. I was a little bit hasty, so it tells me that I'm missing a line. So I missed this one. Cool. Print line. So this should not be print line. This should be system.print. That's what it's basically saying. So instead of print line, it should say print. I could do setter. Yeah, this would work too, right? So that would be set X and set Y separately. Let's try. I don't mind that. My only concern is the middle one, which we're going to get a comma, right? So I want to see how this works first, and then see if we even need to do what you're saying. All right. Let's run it again. So cool. We go in there and we say 5 and 3, and automatically we're going to get an error, right? So that didn't work. So 5 and 3. You know, that's what I wanted to do. So this idea was right, but the set X should be this, and we're going to separate it. I'm going to do set Y. Let's see if that does it. And we're also going to do a next. So we want to avoid, we want to ignore the center input because we don't care about it. We're just skipping. Like almost like an ignore equivalent. We don't have this functionality right now, and it would be nice to have something like that, an input into the vector2. So vector2.in, something like that, or vector2 input, and then we put in our input and it would do our input for us, right? But we don't have that functionality right now. Bear with me, guys. I know it's 11:45. I'd like to finish soon too. I just want to make sure you guys are good. So Y, and then what we want to try and do is keyboard.next. We want to discard the next input. Let's see how this functionality works. We know this isn't going to work, so we're going to do the same thing over here. And hopefully we'll get this idea happening much better than what we had before, instead of using temporary variables. All right, let's run it again and see how that works. So again, we're looking at it and I'm saying, okay, I want to go here and put in 3 and 5, and we got a problem. Okay, let's run it again. We say 3, and then 5, and then 5, right? And that's not bad. That's not the way we want it, but whatever. We can't enter it together, it looks like. So that's something that where I'm getting input, but I'm not getting everything in there like that I want. So the scanner is kind of a weird thing, right? I want to get input, but all at once. Can't do it, right? I got the data, right? But wasn't the way I wanted it to get the data, right? So where it says get this, right? And I want to get the next float, and I don't want to get an input. I want to get this on the same line. So print line obviously is wrong. It should be print, just like this, right? So print line is wrong. It's got to be on the same line. But I can't enter stuff one at a time, X and Y, and I'm just putting this out there to you. Is there a way of entering this on the one line kind of in the way that I've done it? What else can we do with keyboard? So keyboard dot, right? So we can use a delimiter, right? So there's a delimiter pattern, right? So what's the delimiter? So we can say if I hover over the delimiter and I want to get information, right? So how do I get that? So it says, okay, returns the pattern that scanner is currently using to match delimiters, right? I want to set the delimiter, right? So because that's what this is. This is a getter, right? It says contract cure is equal to true, and it's going to return the pattern, the delimiter that it's using. All right, so the delimiting pattern. Is there a way of doing it so I can set the delimiter? So keyboard dot, is there some kind of set? There's a reset. What else? Find inline, find within, has next big integer, has next. These are checking to see if it's next. Matches, locale, radix, remove, skip. So skip the string. Tokens, right? There's also this. And use delimiter, okay? A string pattern. So use delimiter. What does this do for me? It says that if I use delimiter, it's looking for a string. So I want to use a comma. Is that good enough? And how does this even work? This use delimiter thing. So do they give us an example, right? And how would this work, the delimiter? Well, let's take a look at the scanner. So scanner, use delimiter method, and let's see if we can get some kind of thing. So so scanner, use delimiter example. I have my public static point main. I have this, right? And then I said scanner, new scanner string. I pass in the string. This is the string. And then I systemed that out to print line, scanner.next line from the string, right? And then change the delimiter of the scanner to use VAT, whatever the heck that is. And then I'm doing this scanner delimiter at the end. So plus scanner delimiter. So this plus that. All right. So if it's comma, maybe I can do that with the scanner delimiter where I'm saying that. So here's this. Look at that. So scan, and then use this as a delimiter and keep going. Okay, so let's try that out. So say instead of next, right? Instead of next, I want to scan. I want to use the delimiter of this between that stuff. So maybe that's what I can do. So I can say I want to use that, the delimiter, right, for that one. Probably won't have to do it twice, but let's see what happens if I run this thing. So again, I'm going to say 3, 5, and then Exceptione. That's not going to work. Okay. How about if I try it again and I just put 3, 5? That didn't work either. So that totally didn't work. Right? And let's do what we had before, which was that extra variable. So let's go back to next. So that works, the next one, but I have to kind of enter it, a bunch of times. So this use delimiter thing is a dud. All right. So again, these are things we can explore, guys, to see how this works. Anyone else have any ideas or suggestions before we end for the day? Because this is terrible, this entry, right? So Nicholas is fresh out. Anybody else? Let's try this out again. So 3, and then if I put comma and then 5, I'm going to get 3, 5. That's okay, but that's a terrible way of entering data, right? How about this? What if I entered the whole string? So I entered next get line, right? So next line, and when I next line, then I parse the data from there. So in other words, instead of me doing individual pieces like how I'm doing it, I want to parse it. I want to take that string. So notice that where the delimiter is, right? I can use the, this part to basically use the delimiter just like how it's done here. So I scan. Let's go over here. I have this big thing here, and what my delimiter is that I'm going to use is tab or something like that, or VAT. Let's see what this is. The slash, that's the delimiter, and it's going to basically use the delimiter to enter in all this information. So I can kind of break up this string into multiple things, right? So that's kind of what I want. And so if I did something like that, and if I had a temporary string, so var, and let's call this prompt, right? And actually you can do that up here. So something like this, we can say string prompt. Sorry guys, I know I'm running over, but I wanted to give you this, right? And we can initialize it. Let's say capital S for string prompt. We want to do this, and we can say something like prompt is equal to keyboard.next line, right? So the whole line, take the whole line in, right? And then what I want to do is I want to say that prompt is the one I want to do, right? So can I do prompt dot something like I want to create a substring or something like that? Well, we have this. I entered this into scan, right? So scanner scan. I entered this in, right? Instead of using keyboard, I can do it this way, right? So scanner, blah, 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 right? And I want to use the delimiter, and then when I print out the tokenized strings, I can go into has next, and I only want to print out those things, but I ignore the comma. So this is kind of what I want to do. So the way we did the keyboard up here was cool, but instead of that, what if we did this? So I said, okay, I want to have a prompt, right? And I want to have system.in to take everything in. Here's my prompt, right? And what I want to do is I want to say prompt.nextLine, prompt.nextLine. So I get it. The whole thing comes in. Now, is it being left in the dark? No, I get the next line, right? Next line and the whole line. Then I can say, when I get the whole line, can I do something like, can I parse it somehow, right? Is the other part. Or can I make it a substring? Let's go back the other way around. The other way might be to get this, but what I want to do is I want to say, once I've got my entry, right? So for example, keyboard.nextLine. So I can say prompt, get everything, and what I want to return is, can I do a substring or split? Right, so split. And I want to split on some kind of, regular expression, or I want to do a substring with a begin and end index, something like that. Is there a way of splitting, with a delimiter? So let's take a look at split. So string split, Java, and we'll say example, which I can spell, maybe write one day. So split is what I want to do. And so I want to do this. I want to say that I want to split where I want to say that I want to split it. It says let's split the string to be this, right? and here's the regular expression, at, right? Limit is 2, and let's see if I can do it in some way, right? So it says I want to search for this, right? I want to search for this. The limit is only 1, and I want to split it up here, and I want to create a string array of objects. I could do that. String array of objects to get in, and I could do that. So I could say, okay, cool. Let's make it so string. I get this thing, the whole thing, and then what I want to do is I want to split, and I want to search for comma. That's the expression. So anything that has a comma in it, right? And I don't care about limits because I can have more and more commas. I don't care. And it's going to return an array of values. So we'll say values, right? So it's a string array, right? And then what I can say is in one, this is kind of complicated, but I can make a little function for this. This is the cool thing, to do it over and over again. I can say, well, values then is going to fill up my stuff. So I can say that, point1.set, and I want to put in values 0 here and values 1 there, but these are strings, so I want to cast them as parse floats, right? So we want to parse them as floats. So I can't do it there. Can I do parse float in some other way? Right, so again, these are just examples to help you. So if I did parse float, is that possible? Is there some kind of like parse float method or something like that? So, or can I convert it? Just say float, right? So I want to convert from string to float in Java. How do I do that? So it's going to show us float.parseFloat is exactly what I wanted to do, because you can't do this type casting. So for complicated objects, parse float, and I want to do values 0. That was weird. So I want to parse value 0, and I want to parse float values 1, right? Because that is going to do my values for 1 and 0. So this should be kind of what I want, right? If it works, right? And we're going to stop at the first one because I don't want to do this again. And notice that they're all these things. So next line, value split, and then parse float. If this works, is kind of what we're looking for. This is what I'm worried about, the prompt split, where it splits it into 2 strings according to the comma. All right, so let's try this out and see if it works. So run it. So 3,5. Yay! That's what I want. Right? It's way better than doing it the other way. Let's stop this because the other one is going to fail. And there's my little solution that I recommend for you guys. Right? So prompt, instead of making it so prompt is the actual thing. We go down here and we replace this part with 0.2. And then values, we already have values. So we're just going to say values is equal to prompt split. Again, we're going to use the same thing. We have to define it once. Yes? So 0 and 1, where we split. Now, curious, will this do it twice, where I say values is equal to prompt split? I'm rejigging my array. Will this overwrite or add to my array? What will it do? Let's see what happens here, because it's an array. So it's immutable, right? So let's try this out. So I said, okay, so I want the first one to be 3, 4, right? And then 10, 100. And then it says magnitude of the first point is 5, magnitude of the second point is 100, 0.499, distance between the first point and the second point is 0. That doesn't make any sense. So that is some problems. That's definitely issues. We have some problems with some of our code, but it kind of worked, right? Because 10, 100 is the second point, right? So that's pretty cool that it worked out. And we need some, so the magnitude of the first point is, and we need to put a \n in there, right? Because we need that extra space. We didn't include that. And definitely include that in there. So our vector2.distance between point 1 and point 2 also did not work. So that's kind of something we have to look at and see why the distance calculation between point 1 and point 2 does not compute, right? This is okay. It entered the points in there and it showed us what the point is. So you entered for first point and the second point. I need to put in \ins. Actually, do I have to put them? I don't have to put them in there. Let's try it one more time. So run it. So again, I said, let's say 3, 4, and then 10, 20. So the distance is no good. The distance is no good, but the magnitude is okay, right? Distance is no good. Magnitude is okay. So why is the distance no good? That's an error. Let's take a look at that and see what the problem is. Can I go to definitions somehow? Right? I want to go to declaration or usages. Well, here's a declaration. So I get a final vector A and a final vector B, right? Which is similar to what we did with our magnitude. Because remember, we did magnitude up here, right? Get magnitude, okay? And we did this for magnitude. We return a float. And we're supposed to return a float for this one, distance. But, well, it's not working. Why is that? So map that square root float, and, you know, we're getting some values for A and B.
Point one twice in main.
Did I?
You wrote point one twice in main for the distance when you called the distance.
Oh, you're the best. That's good. That's good. Good eye. Good eye. Point 1 and point 1. That's why it's 0, so it is working. Thank you for that. Let's try it again. And so nothing is wrong. Yay! That's good. So 3, 4, 10, 20, and then we're good to go. Guys, it's a beautiful thing. We've got our stuff that we had before, and now this is a great place to put it up on GitHub because we have some examples of inputs in the same line, which you guys need to do coming up for your little lab, as well as everything else. All right, let's put this up on GitHub. So again, I'm going to go to commit. I'm going to flag all those things for committing, and I'm going to say completed vector2d example, right? And I'm going to do a commit and push, so you guys have everything you need for my recommendation. I haven't done any kind of comments. That's what's missing. There's no Java docs. That's also missing. These are things that you need to do for your assignment. Questions around this before we stop for the day? Simple solutions, I think, that we found, and I think they're really good, straightforward, and I think it'll work. There's other ways to do this as well, and you can explore them, but I think something that's like this, where you get the entire line in, as opposed to little parts of the line, is a better way of going. Splitting a string into 2 substrings and sending it into values with a var keyword, var being like auto, that's totally fine, and then using the values here and here is totally okay as well, right? So everything else is the same. It's just that the input was weird. All right, I'm going to stop recording. I'm going to take questions. Thanks, guys. For people who are watching online, thank you. I'll see you guys next week. For people who are here, I'm going to take questions before you guys go.